in this video we're going to look at another operation that we can do with vectors, and this one is called a dot product. So this is for two vectors. If I have a vector v, and I'll just write that in component form here the way we have been doing so far, and another vector w. These could be vectors in R2 or R3 or Rn. Extend this definition to more dimensions if necessary. All right, so if I have two vectors here and I want to think about what's called the dot product of two vectors, there are two ways that we want to think about this, and depending on a textbook that you might look in, they might start with one way and then develop the other, or the other way around. Our textbook starts with a geometric definition of the dot product, which I really like, because I think that it helps students emphasize why would you ever find a dot product. It really has to do with the geometry of this. So this is, in some textbooks, this is derived from an algebraic definition. But our textbook starts with this geometric definition of dot product. So it says that for two vectors, v and w, v dot w, so we put a dot in between them, just like a dot for multiplication, and so this is called the dot product. You would never write two vectors just next to each other. You need that in between. You also would not say times, because we also have a cross product, which we'll talk about a little bit later. So a dot product, v dot w, is how you would read that, and that is defined to be magnitude of v times magnitude of w times cosine of theta, where theta is the smaller angle formed when v and w share a common endpoint, or a common initial point. So if I have two vectors, v and w, that share a common initial point, they really form two angles, the angle here and then the other angle that goes all the way around here. So we're talking about the smaller of those two angles here. Smaller angle formed by v and w sharing a common initial point. All right, so if you think about this dot product in this way, there are a couple of important things from this definition to note. The magnitude of v is a number, a scalar, that tells you how long the vector v is. The magnitude of w is a number that tells you how long that vector is. Cosine of theta is also a number that has to do with the angle, and thinking about triangles or unit circle for that angle. This quantity here will always be between -1 and 1. So cosine of an angle could be negative, could be positive, but it's always going to be between -1 and 1. So a couple of important things here about this definition. One of them is that a dot product gives a number or a scalar for the result. So a dot product gives a scalar. So your answer for a dot product problem should always be a number based on thinking through these. This is a number, this is a number, this is a number. I have three numbers times each other here. The other thing about that is the magnitude of the vector v is always going to be 0 or bigger. That's the length of that vector v. The magnitude of the vector w is always going to be 0 or larger. That can't be negative. But the cosine could be negative. So the dot product could be positive or negative. And whether it's positive or negative really has to do with this angle between the two vectors here. So it can be positive or negative depending on the angle. For this picture that I drew here, that angle between those two vectors that I drew there is an acute angle, less than 90 degrees. So the cosine of that angle, if you think about your trig values, cosine of an angle that is between 0 and 90 degrees is going to be positive numbers. So for this picture here, the dot product of these two vectors would be positive. When you have a positive dot product, that would be when your angle is acute or less than 90 degrees. And if I drew another picture here of two vectors, v and w. And I have an obtuse angle, so between 90 and 180 degrees here. That angle would have a cosine value that is negative. So negative dot product indicates when the angle between them is obtuse. The other thing to think about here that would be relevant is, when is the dot product 0? When could this dot product be 0? And that's actually an important vocabulary word that we'll talk about too. Two vectors, v and w, are said to be orthogonal if their dot product is 0. If their dot product is 0. So that's an important vocabulary word to know. When you see that word orthogonal, it means dot product is 0. But there are actually a couple of ways that that could happen. So if we think about this definition here and think about different ways that the dot product could be 0, well, these are three numbers all times each other. So that could be 0 if any of those three numbers is 0. So orthogonal vectors happen when the magnitude of one of the vectors is 0. So that would be if one of those two vectors, the magnitude be 0, would mean all the components are 0. So that could happen if v is the 0 vector, all zeros. Or we sometimes denote that as just a 0 with a vector symbol over it, the 0 vector, component of all zeros. Or if the w vector is all zeros. Or the other way we could get an orthogonal pair of vectors would be if neither one of them is the 0 vector, but the cosine of the angle between them is 0. And so again, if you think about your trig values, cosine is 0 when theta is 90 degrees. So that would be or if v and w form a right angle. So sometimes when I ask students what the word orthogonal means, they will say that the vectors form a right angle. And that is sometimes the case, but actually the definition of orthogonal is that the dot product is 0. And it might mean that they don't form a right angle. If one of the two vectors is the 0 vector, then that dot product would be 0 as well. So you'd have a 0 here. All right, so we're going to look at, in another video, at some algebraic manipulation with the dot product and some examples of finding some calculations with the dot product.